Well, here's the problem, is I'm Bill Martin, by the way, and I'm building a robot. So many others are, but I'm using a screen to tell me where the echo from the ultrasonics also is how far out it gets from the robot. And so I'm matching up the lines with where the servo motor is turning, the sweep of angle, and match that up with the lines that on the screen, so that I can get a visual indicator of what he's seeing, what the robot is seeing. My problem is that I want to do this all with the one Arduino, and pardon my hand, but my problem here is that I think I've used up all my pins. Now, I've scoped out a number of these pins, and they're being used by the display. So I've got only probably one or two. I think maybe pin on the Arduino. We got pins 8, 9. Those are both, 8 and 9 are both being used. And I'm using, actually I'm using 10, 11, 12, and 13 for other reasons. Primarily for the servo itself. Please forgive the mess here, but primarily for the ultrasonics and the servo motor which it sits on. This is the laser, not rangefinder. It doesn't tell distance, but the laser is oscillating at a frequency picked up by this lens, and that is we'll just give it on and off that he's detected something. As you can see, my hand is off camera, but as my hand gets closer, as you can see that light come on, he's saying, okay, I can see something. The reason why this works so well, and it doesn't work with other infrared, it doesn't work as well with other infrared, I just showed the wrong thing there, but with other infrared signals, is that they're so sensitive to the lighting, whatever lighting you have. Here's one right here. They're so sensitive to this lighting here. You bring that into focus. You have the infrared LED and then the infrared detector, and they work fine. And you can tweak them with these pots here, and they work fine as long as the environmental lighting conditions stay the same. As soon as they change, even sometimes just a little bit, like turning on a lamp or something, these don't work anymore. All of a sudden you're detecting something constantly, or you can't detect anything at all. Where on the laser system here, regardless of the light, the lighting conditions, the environmental lighting conditions, this thing will reliably detect something is in its path, in its way. And you can see I'm just, like I say, my hand's off camera. I apologize for that. But as my hand breaks that beam, it detects it. And now I've gone out maybe 3 feet, 4 feet, maybe a meter from the laser, and it doesn't matter what I do. It doesn't detect it. I get in about 2 feet, boom. Now I'm crossing through the laser and it's detecting it. And the laser is oscillating at 340,000 times per second, at least according to the paperwork that came with it. So it centers in on that frequency. It picks up that frequency with the lens, and the lens is very important. The glass lens or plastic lens that they have, polycarbonate lens that they have here, that focuses the laser light to the sensor, is very important. I did have to glue it down. It came off out of the package, and I'll show this lens. I'll show where I got it on eBay. But it is very reliable in terms of distance that it detects. And the ultrasonics, as probably a lot of you know, is also very reliable. But I needed something something else that would supplement the ultrasonics, because the ultrasonics, depending on the angle of the object that it's coming up towards, the robot is coming up towards, depending on the substance that the object is made of, the ultrasonics doesn't always work. So, along with the ultrasonics and the infrared, it seems to be a pretty good combination to give me a good yes or no. Well, what I did was I also wanted a visual for myself, or for anybody watching the robot, which would probably be just me, watching the robot. I wanted a visual. Here you have the origin of the laser is here, or I'm sorry, the origin of ultrasonics is here, and as the ultrasonics swings through on the PWM, or on the pulse width modulated servo, on the servo, it would sweep out a path, and you can see the path kind of being swept out there, and then you have some information displayed, which I'm going to take out. That's just for troubleshooting purposes. It tells the number of inches and whether or not the laser has been triggered or not. But you can see the path that the ultrasonics is trying to, or the sweep pattern that the ultrasonics is trying to give on the display, and that's what I wanted. I wanted it to do that. If I move I'm not showing this now, but if I move that, you see a little bit better. Well, what I need to do is I need to tie in the movement of the servo, of course, with the ultrasonics itself. Right now it's not tied in. Right now the ultrasonics is independent of the servo movement. Well, that's not going to work. So if I so right now I want to tie in and the ultrasonics or the servo to the ultrasonic board, which is this board. The board that the display is on is controlling the ultrasonics. And I want to bring in, and all I need is one pin, because power I will get externally. I have a lithium battery that's supplying all the power for everything. And I'll show you the robot. But on the back of the Arduino, as you know, this is pin 8. Here, I don't have, let's see, I got kind of a pointer here. Excuse the hand. You know, we have pin 8, 9, 10, 11, like that. Well, some of these pins are used by the display, and I can see that when I go the scope. But some of them are not, and somehow I knew that I could use these pins, the ones that I have the wires kind of sloppily. I really didn't like doing that, but kind of sloppily tacked down to the back of the board. But it works, and it will work. It's reliable, although it's a little messy. But I need to find the pin that I can put the servo on to control the servo, tie it into the direction of the ultrasonics and the laser, not rangefinder. I keep wanting to call it a rangefinder. The laser device that will show a certain distance has been met, or a certain object is at a certain distance, I should say. Anyway, that's where I'm at with it. And let me show you the robot that that this will attach to. Now, the signals that I'm seeing on the Arduino, if I go to pin 8, because I need to find a pin that is not used by the display and one that I have not already used. And if I look at pin 8 on the Arduino, as you know, it's just a digital pin. As we can see, there's lots of activity on there. That is the display is doing something. the display where you saw the lines going out and trying to see a pattern of the echo of the ultrasonics. This is one of the, I don't know what that pin particularly does, but it has a lot of activity on it, so I can't use that. That's pin 8. This is pin 9. 9's doing something very similar, so I'm not going to be able to use him. That is a Rigo DS1054 scope, by the way. Very good scope for the money. $399. I think I ended up paying. I bought an option. Bought one of the options with it. One of the decode options, the I2C decode option, an SPI decode option. I think I ended up paying $550 total for it. But it's been a very good scope. I'm not zooming in on the screen because it's not really important that you see what exactly the data is there. I don't know what the data is, other than it's being used by the display to display the lines for the ultrasonics. And then the 8, 9, 10. See, 10. I'm using 10. I'm using 10 myself for something for the ultrasonics. No, I'm not. No, I'm wrong about that. I'm not using 10 for anything. 10 is not showing anything. 10 is just showing some noise. I don't have it grounded because I don't need to just for this kind of test. I don't have the scope grounded. But if I zoom in on a little bit on that, you can see that there's just really nothing but just some noise on that pin. I might be able to use him as, all I need is one pin to use him as the pulse width modulated pin to go out to the servo to tell him what position it goes to. And I'm using since this is an Arduino, I'm using the Arduino IDE, and I'm using the servo.h library, or the servo library, and which is a very good library. You don't really need one of those 16-in-1 controllers. If all you need is 1 or 2 servos, you can use the library, and just if you got a couple extra pins on your Arduino, then you're fine. But anyway, I'm going to give that a try. I'm looking at pin 14 there, and I'm seeing you. I don't know if you can see that on screen or not. Yeah, you can see a little pulse there. I don't know what that is, but I'm not going to end up destroying it or wiping it out if I put my solder my wire to it, my servo wire to it. So we're going to give that a shot, and then we'll come back and see if that works. Well, I did find a pin. I found pin 10 on the Arduino that was not being used. It was actually being used by an SD card that's built into the display. And those are the pins I'm using because I'm not using the SD card. Well, as you can see by Shaky here, I've got either some additional signals coming off of that pin, or my code is causing it to kind of have a nervous breakdown. The ultrasonics is working, but it's not. There's a bad spasm there. It's not really doing a very good job of sweeping out an area. So I've got to figure that out, and when I do, I'll show you the solution that I get. Well, the ultrasonics and the servo motor and the laser distance measuring trigger it uses too many pins on the display. I mean, along with the display, if it's connected to an Arduino. As you can see here, This was the Arduino that it was connected to. This is the one that I had all the wires kind of bodged in to, and it was working to a certain degree. You saw the shakiness that I could work out with programming, but in the middle of that, in the middle of working out the programming, I decided that I'm going to go to a Mega. So now I've got the display attached to the Mega. Here, sorry for the poor cameramanship, but I've got it attached to this Mega, and the Mega is, of course, got a lot more pins available. This got this whole back row of pins available to it. So I'm going to attach the display to it. You can see the display is working. I don't know if you can see that or not. Working slightly, but it has no signals coming in. So I'm going to have to transfer all the pins that are soldered here onto this Arduino, onto the back, and transfer them over to just insertion pins, DuPont pins probably, to various pins on this back row here. So that will allow me plenty of pins to put the ultrasonics, the laser distance measuring, and a control for the motor, because this ultimately has to send signals back to the motor, or the two motors, the motor controller controlling two motors to tell the robot, to back up, to go forward, turn right, turn left. And so that's the next attempt will be to do that. So that's where I'm at in that, and I will put a little more of the troubleshooting on that. I'll film a little more of the troubleshooting and the programming with that, and we'll see what happens. I take a quick shot of the robot that this will eventually go on, the ultrasonics and the range finding, and this is a homemade, about as homemade as you can get. I'll go in more detail on the robot as time goes on, but for right now it's basically two motors bought at a surplus store, which I hate that when people say that, because that means I can't get those motors. But I have seen similar motors on eBay, and I just mounted them to aluminum plate. As you can see, it's a large 1 foot by 1 foot aluminum plate. I mounted those, and sorry for the cameramanship here. I mounted the motors on the aluminum plate, and in the middle there you see the controller and the battery. The controller is Arduino controller for the motors, Cduino actually, and the battery is a 5,000 milliamp hour LiPo battery. And right now I just have it going through some standard steps in the programming. Nothing. It has no detection capability in terms of its environment, which is why I'm creating the ultrasonics. Anyway, this is where it will go, and we'll get into detail on it as soon as I get the Mega working with the display. So what I'm going to do is I have the display in the Mega. As you can see, pardon the reflection, here it is trying to draw a line, but right now it's going from 0 axis to 0 axis, so there's nothing telling it to draw a line out here in the sweeping pattern because there's nothing hooked up, because everything is still hooked up over on this Arduino. So what I got to do is desolder these wires and affix them, I don't know, cut a new length in them or something, cut a new, clip them and cut the cable such that I can fit them into this connector here in the right place. What that's going to require is writing down where these go and then matching that up with what's in the code. And I'll do that, get them moved over here, and then I will check back with you. I wanted to just touch on the code with you just a little bit, so you can see what I'm doing. Is actually the body of this code is from Adafruit. They're the ones that wrote it, and I've just took it and am using it in different places to do the echo, or rather the trigger and the echo pulse width weight, or pulse weight, to find out what the distance is that the sound travels, and then that gets converted by just a simple formula into an actual distance in inches. So we start out with defining some variables here. Those off the screen, sorry. Long, duration and distance, and then distance in inches. And we fill the screen, the TFT screen, we fill it with black. We just make it a black background. We set some variables, x1, y1, y2. These are our xy coordinates. And then we go for x2 equals 0, while x2 is less than w, which is the width of the screen, x2, and we add 6 to it. So we jump over 6 at a time until we reach the width of the screen. And each time we're going to trigger, here we're going to trigger the pin with a 2 microsecond pulse and a 10 microsecond pulse. And then we are going to wait, pulse in for the echo pin. We're going to wait for something to come back. When it does, that will be our duration. Our distance is going to be our duration divided by 2 divided by 29.1, and that's Adafruit's calculation. I just went with it. Our distance in inches is going to be that distance divided by 2.94, and then we're going to draw a line. We're actually going to draw a line based on that figure, based upon the DI, the distance in inches, with width divided by 2, which puts it up in the top middle of the screen, as you saw, the start of the line in the top middle of the screen. And then the bottom portion of the line will go y1, and then we'll go x2, and then the distance times 4, and I ended up having to do that to give it a decent length on the screen so that you could see it. It's just a matter of convenience. It's just a constant. We are going to constrain, and then we do want to move the servo. So we're going to constrain its movements and base its movements around x2, which is the width as it goes through its sweep. The servo goes through its sweep from 0 to 180, from 0 to 180 degrees. And then we write that degrees that we want, we write that to my servo, which is writing to the servo device. And then I just do a little diagnostic. I print line that position, and I do a delay of 100 of a second. And then we start over again. So that's what the code is doing. And my job now is to figure out which pins I'm using for echo, which ones for trigger, which ones I want to use for the pulse width, and then reassign those to the available, now a large number of available pins on the Mega. And we'll see if we can get the screen back the way we had it, plus start on the servo not being so shaky as you saw. And I will be back shortly. Now I'm going to be soldering just some DuPont wires onto the wires that come off of the ultrasonics and the laser infrared detector, so that they can easily be plugged into the Arduino board. Just wanted to let you know where I was. Okay, it seems to be doing pretty much what I want it to, at least on the bench. Next step, of course, is moving it to the robot. Okay, you see the ultrasonics panning at about 180-degree sweep. Alright, now if we look at the screen down below, the screen is showing us, and I'll zoom in here, as you see it panning, the screen is showing us the depth or the echo of what it sees, or how far along it sees as it pans through that 180 degrees. You see some lines are longer, some lines are shorter. Well, that's just its interpretation of the echo of the signals that comes back, and how the duration of that signal from trigger time to echo pickup time. And I'm standing here behind the camera. The camera's in the way. There is a place, you see some of those long lines. There is a couple places where it's at least 10 or 12 feet to a wall. So that it's going to see that as infinity. And for the most part, it looks like it's picking it up relatively accurately. Now, that's why I've got the laser. Nope, excuse the jostling of the camera. I've got the laser on there, which you can see the light underneath there. Here's the lens, and then there's the laser. Oops. See, that's what happens when you have a messy bench. And the laser light reflects off and will give an absolute of what it detects or doesn't detect and how far away it is. I don't have that reflected on the little screen. I'm thinking about doing that. Adding a little red block or something where the laser detects an object. I might put that there, I might not. But for right now, I'm declaring this a victory, because as he sweeps, he will give a visual indication. We're doing this all on the same 2560, Mega 2560 Arduino. And he sweeps, and then the next step will be, this will send information to the motors to tell the motors whether to stop or back up or go forward or left or right or whatever. And I've got plenty of pins for that still left. So this is my first usage of the 2560, the Mega. I've been using Arduino for everything else. And looks like it is doing what it is supposed to do. So the next step is we will move this over to the to the robot, and see if we can integrate it into the robot. First of all, just simply get it to do what it's doing right now, hooked up with a little better wiring harness and some sort of, the wiring solution has got to be better than what it is right now. And second, then integrating the program that runs the motors right now, integrating that into this program. So you got one Arduino program running, controlling all of these things, controlling the echo, the laser, the screen, and the motors, which shouldn't be any big issue for as powerful a chip as what's on the Mega 2560. Well, I've shown you this before, but he's working pretty good now. He's scanning his 180-degree sweep, as you can see. He's doing it without the shakes. And he is drawing on the display. Let's see if I can zoom in on this while we're live here. On the display, he's drawing what he sees as the depth of the echo that he's getting. And you'll see some little red, I don't know if you can see it, actually that's going to come through. But the lines will turn red, and my hand is getting, my thumb's in the way there, and my hand is getting close. You'll see some little red circles in there. If the wires weren't in the way, you could probably see them. But I don't dare move the wires yet. I got my wiring solution is yet to come. he'll draw little red circles where the infrared detector sees the obstacle, and at the distance that he sees it. Excuse me. And now, though, the challenge has changed. Now this is working about the way I want it to. There'll be some tweaks. With this, I get a visual indicator, and I've got a sweeping laser beam that gives obstacle at a certain distance. It's not a rangefinder. I may have called him a rangefinder earlier, but it's not a rangefinder. It just simply turns on when an obstacle comes within about 2 feet. And that's a last-ditch effort to keep this robot from running into something. But now what I've got to do is I've got to marriage this display and this ultrasonics, this distance measuring, and obstacle avoidance with the motors and the motor control board. So what I want to do is run just a couple of wires from here in the Arduino code. If you're familiar with Arduino code, I'll use software serial, pick a couple of pins off of there, use those pins. Since this is a Mega, I now have plenty of pins that I can do this with. Use those pins and then run a software serial over to the motor control board. And the motor control board is here. You can hear him hum a little bit there. Because I've got him. Oh, that is lousy cameramanship. The motor control board is a Seed 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 motor control board. It's one of their first ones, one of the original ones. I've had it for a long time, and I was able to find code to get it running, not from their website, but off of the web. And I'll show the code later. It's from a person. I wrote my own code, but it didn't work. So a guy named Chris, or maybe a girl named Chris, wrote the code that actually makes the motor control board work and control 2 motors. Well, now I need to tell this motor control board what the ultrasonics has done, what it has seen, so that I know whether to turn left, right, stop, angle off, dog leg right, dog leg left, back up, or whatever. So I'm going to use software serial on both of them, assign some pins, and then pass the data serially in just some sort of very simple code. The first byte will be the degrees that he's detecting the object, or he's detecting a clear path. Say, I really want to concentrate on the clear path actually for right now. And so many degrees he's detecting a clear path. Well, then that will be interpreted properly as where am I currently, and that degree point will be where am I pointed currently, and that degree point will be where he'll turn and try to go. And so because the robot's whole function will be to find the most open spot and go to it, and of course he's going to wander around, almost aimlessly, looking for the clear spot that he can go to, and then eventually I'll give him a more goal-oriented kind of programming, as much as you can do within an Arduino anyway. We've got some future plans. Maybe a Raspberry Pi can do the ultimate thinking, but that's off in the future. I just want to get the thing up and running and get him running around where he's not running into walls right now. So this is definitely a bottom-up approach. Now the robot, I used to give them names. Actually, I gave one robot, my first robot back in the 80s. I gave it the name Ivan Holinsky Kavar, and the roar of laughter that I received when I would tell people the robot's name. I don't name them anymore. They're just robots. That's all they are. I called them intelligent servo mechanisms for a long time. Just avoid the word robot. Well, now I'm back to robot, and that's what it is. So anyway, so I've got to get the software serial between the two working, pass some sort of information, and then the motor control board will actually get the information. The ultrasonics will obtain the information, do some intelligence on it, some massaging of the data, pass it back to the motor control board, and he'll take it then, and I can have him act on it. So that's where we're at this point. And once I figure that out, I'll gladly share it. Well, I'm making some progress. Okay, what I've got is a line that goes from pin 18 on the mega board, or yes, pin 18 on the mega board over to pin 6 on the Arduino motor board. And it's just a makeshift line to go made from a string of DuPont lines, DuPont cables, to go over and just make contact between the receive and the transmit, or the transmit off the mega to the receive on the motor board. And then I put some code in that says, and I'll point over here if you can see it, I put some code in that defines over on the motor board what the receive pin is and what the transmit pin is. I'm using software serial, and then I just read that constantly, and what you see is what I'm reading coming from the mega board, coming from the ultrasonics board. This line of data is coming from that. Now the data is meaningless at this point. I am sending the distance in inches that the ultrasonic reads, but it's not coordinated with a direction. So the next step will be to coordinate it with a direction, and I'm only going to have like 4 directions. North being straightforward, and then northwest, west, like that. I'll use some sort of nomenclature for the variables NW, N, northeast and east, and just 4 or 5 basic directions there, so that it can just generally know. I mean, there's no sense in being more precise than visually or through the motors it can handle. Through guiding the motors, it can only be so precise anyway. So that should be have enough precision to it so that the say about 5, 6, 7 directions, it'll know that yes, I'm in a trap and everything is only about 8 inches away, so I'm going to back up and I'm going to turn, and I'll have him turn in a random direction and go somewhere. But the key here is that we are successfully sending the inches of distance that the ultrasonic sees over a line from its transmit to the receive pin of the Arduino motor board. And then now the Arduino, once we get the direction with it, which I might make just 1 byte, just have a code in there where, from 0 to 10 means one thing, from 10 to 20 means another, from 20 to 30 means another, where I just have 1 byte, and maybe in code actually both the information about the inches and the direction of it in 1 byte. I'll see if I can do that. If not, I'll have to send 2 bytes of data and give it the information it needs in order to make a decision on the direction. But I just wanted to update you there of the code that written, and on the code written, and what I did, what pins I used, and what I did to make that work. On the mega side, where he's the ultrasonics, I just used serial 1 port, which is pins 18 and 19. I didn't have to use software serial, and it's just a couple of lines of code to declare serial 1, parenthesis 9600 parenthesis, and then down below serial 1 dot write, and then I'm writing the the inches, DI, which is the distance in inches, DI variable, writing that out on that. And that's what I am successfully reading back on the motor control board. But I just wanted to catch up on that, and when I get to the next step, I will share that. Thank you. Now that we can successfully communicate between the mega board, ultrasonics on the mega board and the motor board, the Arduino on the motor board, via UART, I'm making some wires just for more permanent. This will be the permanent wires. So I took a couple wires, solid core. I don't know, I guess they're about 18 gauge or so, and you know, used a drill to twist them together to have a twisted pair. And then I cut some DuPont. See if I can get a little closer with that. Cut some DuPont cables, or wires, DuPont wires. Cut them. Tried to match the color, and then I'll just solder them in. And it'll be 2 males on one side and 2 females on the other. And then we'll have us a nice UART cable that can go between the boards once we get to the robot. You know, I just realized they're 42 minutes into this tape, and that's long enough. This is my first video, and Bill Martin #1, and this is the robot trials. And I just want to say thank you for watching, and subscribe and click like if you like, and please leave comments if there's things I need to change. I know there's some things I need to change. I need a cleaner environment, cleaner desk, and I need to do things better. But and I'll do that. But thank you anyway, and we'll see you next time. Expect a continuation of this robot build shortly. Thank you so much.